Today on Build, it's a game with Phaser.js. Stay tuned. Hi, and welcome to Build. Build is a show where you learn to build technical projects step by step, and I am so excited about today's show. We're going to be using JavaScript and the Phaser.js library to build an arcade-style game. I'm actually going to go through all the code line by line so you understand exactly how to build the game yourself. You'll learn about the Phaser.js library and how it works, and you'll get all the code so you can take the game and build on top of it to make your own game that's more complicated and more fun to play. All right, so without further ado, let's get started on today's project in Build. I think it makes the most sense to start with a demo of the game itself. So I've moved into the actual folder where the code for the game is. We can go ahead and hit a dir, and you can see there's a couple of files, an index.html, a shoot.js, and an assets folder. The README isn't important. We can ignore that. So what I want to do is run a server. This needs to be run off of a server. So I've got the simple HTTP server installed here. The way I'm going to run it is with the Python command, because it's written in Python, http.server, and then I'm going to give it a port, and actually it should be Python-m, HTTP server, and I'm going to run it in port 8080. Now, if you have a Mac, you don't have to do anything to execute this command. It may be a little different, but look up simple HTTP server, and on the Mac, you can run it from the command line. With the PC, you do have to install Python and the HTTP server software, although you can find out how to do that by doing a quick Google search. It's pretty easy. So right now, I've got a server running on port 8080 inside the folder that has my code. So I'm pointed at the code folder, and I ran the commands to run the server. Now, once we actually run the game, you'll see the server will echo some commands. So the game will now be at localhost 8080. And there's the game screen, and you can see as I play that there's some messages here on the server. But the game is very simple. I'm simply going to move the crosshair to the alien, and I'm going to hit the enter key to fire. And I'm either going to hit like that or miss like that. When I hit, my score increases, and when I miss, my score decreases. The game lasts 1 minute. So once the timer gets to 60, the game is going to stop. So let's just complete this game so you can see the ending. Let's see if I can get over 100. Oh, doesn't look like I'm going to make it. Oh, got it. Need one more. Just out of time. Okay. So that's the game. Pretty straightforward. You can see the messages here from the server. I'm going to keep that running in case we want to test again. So the files for the game. We've got the index.html file. We've got the shoot.javascript file. And obviously this is the heart of the game. And if we look, the whole game is less than 200 lines of code. Pretty good, huh? So this is the heart of the game. That's where we're going to be spending most of our time. And then we've got the assets folder. The assets folder has got the sprite sheet for the alien. And you can see here, that's what makes it rotate back and forth, is this sprite sheet. We've got the background graphic, the crosshair graphic, the sprite sheet for the explosion that occurs when you hit, and then we've got 3 sounds. We've got a sound that occurs when you hit the alien ship, the piano music in the background, and a sound that occurs when you shoot. So that's all of the assets. We'll come back to these as these are loaded in. Now we'll take a look at the index.html file. And there's really nothing to it. We've got, of course, our basic document structure for all HTML files, the title. Here in the style sheet, all I did was I defeated the margins that are in the default style sheet. There's usually a 3-pixel margin between the edge of the content and the content itself, or the edge of the browser and the content itself. Here I'm setting that to 0. So you can see if we run the game, this is right snug up against the edge. There's no space there. So that's all that the style sheet did, was defeated that space that's in the default style sheet. Then we load a couple of scripts. So this is phaser.js delivered through the CDN, or Content Delivery Network, which is optimized to deliver the code quickly. So phaser.js is the library that I'm using on top of JavaScript to build this application. And phaser.js is a really cool, really complete library for building games in JavaScript. I'm actually not taking advantage of even a little bit of the power available in Phaser. You can see there's a whole bunch of tutorials, shows you all sorts of games that are made in Phaser. It's a very cool and very complete JavaScript gaming library. And once you get into it, you'll really enjoy using it. I'd encourage you to look at some of the examples here, because while this is designed to be a simple first game, you'll see examples here of varying complexity in various types of games. They have platformers, they have games here with orthogonic views. This is called an orthogonic view, where it's kind of viewed from above at a 45-degree angle. So it's really tremendous what you can do. And all of these games, of course, run in the web browser because they are essentially JavaScript. Phaser is built on top of JavaScript. The Phaser website also has some tutorials, making your first game, getting started, and some information about putting games on Facebook. Has downloads for the libraries, and a really cool community that is pretty good about answering questions in the forum. They have a Twitter, a Slack, a Discord. So pretty much any way you'd want to communicate about this library, if you're interested in using it more, is available for you. All right, so let's take a look at the JavaScript. Now, at a high altitude, the way that Phaser games work is there is a configuration section, there is a preload section, a create section where the game is initially drawn and created, and then there's an update section, and this manages your game loop. So this update keeps happening so many times a second, and that's where we move the alien spaceship, check for user input, etc. These functions at the bottom are functions I added. A hit function that occurs when the player hits the alien ship, a miss function that occurs when they shoot and miss, a reset player function that occurs after a hit to reset the player in the center of the screen, and an endgame function that essentially ends the game. So it probably makes sense to start with the configuration here at the top. The configuration comes directly from Phaser. So I'm not using all of the configuration options, but this is good to get us started just for this first run through with a Phaser game. So if we look at the very top, the type of game, there's several different types of games here. Phaser auto detects the type of game. Essentially, this is whether you're going to use WebGL for the game or not, WebGL being the graphics library. So this makes the determination automatically based on the user's system. This is usually what you'll put here instead of specifying WebGL or the other option. Width and height is the width and height of the game. So our game is 800 by 600. The physics module, if you're going to use any type of physics, Phaser has a lot of physics built in. The only physics I'm using is a little bit of gravity and also acceleration for the actual crosshair. So here we're determining we're using arcade physics, and we're just configuring the gravity. The last part of the configuration, we're going to configure what are those preload, create, and update files called. It makes as much sense to call them preload, create, and update as I did as anything else. So I simply specified preload, create, and update here. And that's the whole game configuration. The game is the basic element on which everything is built. So on line 19, we're taking the game, we're declaring an instance of a phaser game, and we're giving it that configuration that was created on lines 1 through 17. So you create the configuration, and then you send the configuration to phaser. And this essentially wakes up the phaser library and sets up the game configured the way that we specified in the config in lines 1 through 17. I have a whole bunch of global variables. The way phaser works, you're going to have to share objects often between preload, create, and update. So I'm having to declare these as global. So this object on line 21 represents the player, the alien or enemy on 22. Enter is the enter key, and when that's hit. Shot is the actual shot when someone presses enter and shoots. X speed and Y speed are the speed at which the player's crosshair is moving. The alien speed, X and Y, and I should mention X and Y are separate because we're moving along the X axis and the Y axis. Those are separate in our code, so we have a separate X speed and Y speed. Although for the purpose of our game, these are always going to be the same. So we also have an X and Y axis speed for the alien. How fast we want to accelerate. I set this as a constant so I could play with it and try different values to make the game more playable. So I tried 2 and 4 and 12, and this affects the acceleration whenever we move. You'll see this used later. Then we have the alien acceleration, which I kind of made a variable instead of a constant because I was thinking about changing that throughout the game and accelerating the alien to make the game harder. Accuracy. This is another one I set because I wanted to play with it, and I wanted to say how accurate do I want to be when we shoot. So in the game, if we go back to localhost 8080, when we shoot, how close does the crosshair have to be to the alien in order for it to be a hit? See, that's a miss. That was a miss. That was a hit. So the accuracy number I use to adjust how accurate you have to be. So if I set 25, the game would be twice as hard because you'd have to be much more accurate. The score, of course, is the score. The score text and the timer text are the text that you saw on the screen for the score and the timer. The timer is the number of seconds. The interval is the actual counter that runs behind the scenes. So when the timer is able to change every second. And then we've got our game over flag, which of course starts as false, but when the game is over after 60 seconds, that will switch over to true. All right, let's look at our preload function. So our preload function, this is the one that runs first. And here we have to preload all of the game assets. We want to load all the assets, obviously, before the user starts playing. Otherwise, we're going to be referring to assets that don't exist in memory. Now, the way this works, these assets also become global assets through these labels. So I can access this particular image background through this label, and this is where it lives. So it lives in the assets folder background. So if we go into the assets folder, background, it knows what we're referring to. So we're going to load the crosshair and give that the global label crosshair. That's an assets crosshair. So for images, it's this.load.image. For audio, it's this.load.audio. So the shot is the sound for the shot at shoot.wave. The hit sound is the little sound that we play when there's a hit. And the background music is that piano that plays while the user is playing, and that's at assets.piano.mp3. Gave that the label background music. Now, sprite sheets are used for animations. Sprite sheets are multiple states of an element that are loaded, and here we have to define the sprite sheet. So the sprite sheet for the alien is called alien. It's at assets/alien, and the frame width and frame height are 100 pixels. So let me show you what that means. Let's take a look at the alien sprite sheet. So each one of these boxes is 100 by 100. And what it does is it rotates the different states of the sprite, giving the user the illusion of animation. So it runs through all of these states in a second. It's not going to be smooth animation. A typical, I think, cartoon or animation is 30 per second. So this is 10. So it's going to be kind of chunky, but it works for our purposes. So 100 by 100, and then there's 10 individual states for Alien JS. The explode sprite sheet, again, is 100 by 100, and it's called explode.png, and that's the little explosion. So each one of these boxes, again, 100 by 100. And when you run these together, it looks like a little explosion. Sprite sheets can be much more complicated than I have here, but I like to keep this very simple because, of course, this is an example that we're running through for your first game in Phaser. Alrighty, so far you've had a look at some of the code for our game and you've seen how the game is played. I hope you're enjoying this video. If you are, go ahead and smash that like button, subscribe to our channel here on YouTube, and hit that little bell so you're alerted to every new episode of Build. Now that our preloading is finished, we have all of these elements in memory, our background, crosshair, etc. The create function is going to run, and now we can set up all those elements. So first, we're going to add the background image. We're going to add it at the X and Y coordinates 400, 300. We're always measuring from the center of the object in Phaser. And the item we're adding with this .add.image is background, which again refers to the key here that we created when we loaded the image. The next two lines add the text for the score and the timer. When we add it, we use this .add.text. The X and Y position, 16, 16 in the case of the score. The actual text we're adding, which is in this string. And then we set the font size and the color. We repeated that process for the timer text, which is at 600 on the X and 16 on the Y. And the text is timer 0 initially. Then we're going to add our alien sprite. Remember, our alien is an animation that has the different stages. We're going to add it with the physics package from Phaser with this.physics. We'll add the sprite at 200, 150. And again, alien refers to the key we gave it when we preloaded it. So we've loaded the alien sprite sheet. Set collide world bounds prevents the alien and the player from going off the side of the screen. When we play the game, you'll notice that as the alien floats around, when it hits the side of the screen, it changes direction, and the player cannot go beyond the side of the screen. And that's because of the set world bounds option is set to true. So we add the alien with physics, we add the player with physics. So we can take advantage of the built-in movement tools in the physics package for Phaser. So we add the player, which is the crosshair graphic at 400, 300, which is the direct center of the screen, and set the world bounds. Now, this particular game operates off of the keyboard. So we set a cursors object with this.input.keyboard create cursor keys. That's the up, down, left, right keys on the keyboard. We also set up the enter key, which is going to be referred to as enter with this.input keyboard, add key, And then we have a constant for every key on the keyboard through phaser.input.keyboard.keycodes enter. It's a long way to go, but essentially in Phaser, this means the enter key. So we're referring to that as enter using this.input.keyboard.add key. So the keys that Phaser is going to pay attention to are the arrow keys on the keyboard and the enter key. Then we add our sounds, the shot sound, the background music sound, and the hit sound that plays when the enemy is hit, when the alien is hit. So we just use this.sound.add, and we create references shot, background music, and hit sound. We have two animations to create, right? We have the animation for the alien, and we have the animation for the explosion. So we're going to key the animation for the alien as cycle, and we're going to set up the animation by referring to which frame numbers in the sprite sheet we're going to cycle through. So from the sprite sheet alien, which we set up earlier, we're going to start at cell 0 and end at cell 9 at a frame rate of 10 per second, and we're going to constantly repeat. It's going to be on a constant cycle. So from 0 to 9 in the sprite sheet alien, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how that's set up. We set up the explosion with the key explode. And again, this time the frames are 0 through 4 at a frame rate of 10 with no repeat. If we look at the explosion, 0, 1, 2, 3, 4, no repeat. Because that just runs every time you hit the alien. We want to run through it, and that's it. We then set the animation for the alien on. So we set alien animations or anims play cycle true. Remember, this was called cycle, so that sets the alien from doing that animation. And if we look at, remember, the animation is not the movement of the alien. The animation is this back and forth as it cycles through the various cells. The movement is controlled separately. There's no animation on the crosshair, but a little bit of gravity affects it, which is why it starts sliding down. Makes it just a little more realistic. All right, so we've got our animation set up for the explosion. We're playing our aliens animation. We turn on our background music. And this is straight JavaScript to set up an interval where every 1,000 milliseconds, the following happens. We add 1 to the value of timer. We change the text of timer. And we see if timer is greater than or equal to 61. If it is, we set game over to true and we run the end game function. So this is running every second, essentially to update the timer and test for the end of the game. So if we watch the upper right-hand corner of the game, this is what's updating this timer here every second, 1, 2, 3. And when we get to 60, this same routine is going to realize the game is over when we're greater than or equal to 61, and it's going to stop the game. Interval is the object that contains this interval function that's running. All right, on update, we test to see if, first of all, game over is true. If it is, we return out of update. Now we're going to deal with the alien movement. Now, we kept the alien from moving out of bounds, but if the alien's X position is greater than or equal to 750, we're going to set it to 749, and we're going to times the speed by -1. And then we're going to set the velocity using physics to that speed. What this does is it turns the alien around when the X position is greater than 750. So when we hit that right side of the screen, it turns around. So watch the movement here. I'm going to log out the alien's X position. And remember, when we get to 750, it's going to turn around because of this particular movement. And actually, let's not put that here because that's only going to do it when we turn around. But let's put that inside the update function. So now if you watch, you're going to see the alien's X position tracked. So let's get our game started. Let's open the developer tools so we can see that X position. So watch what happens when we hit the wall on the right-hand side, which has a value of, or is that 750? So see, it goes back down. So let's go back here. We can see where that happened. Right, 742, 750, and then back down. So that happens because of this first piece of code. Now, if we don't hit the wall, we simply keep moving in the same direction by adding to X, which is alien's X position, the alien speed. Now, you might be wondering, where did the alien X speed come from? Remember here, we started with alien X speed 1 and 1. So we can change that anytime we want during the gameplay. Now, of course, not only do we have a right side, but we have a left side to contend with. So when the alien hits the left side, alien.x is less than or equal to 50. Again, we move it to 51. We multiply the speed by -1. When the alien is moving to the right, the speed is positive. Alien X speed is positive. When the alien is moving to the left, alien X speed is negative. So these lines simply flip the sign, set the velocity, and if we don't hit the wall, we just keep moving in the same direction. So X speed determines the speed and the direction, and it's moving that many pixels at a time. So we need a left and right, and of course we need a top and bottom. So these two lines handle the top, or so this handles the bottom if y is greater than or equal to 550. Same routine. Set the alien y to 549, reverse the sign for alien y speed, set the velocity. If we haven't hit the side, we just keep moving in the same direction. And this guy handles the top. So that's what's keeping our actual alien ship moving around and hitting the sides. So hit the bottom, it reverses, it's going up. Now we're going towards the left. Now we're going down. When we hit the side here, we'll start going towards the right. So that all happens due to that piece of code. Right? These if-then, they're constantly monitoring the position of the alien ship and making adjustments to reverse the direction as necessary. So here, fairly simple. We're testing for the cursor. If the left cursor is down, then we're going to decelerate the X speed, right? Because we can move either in a negative direction or a positive direction, and we'll set the velocity of the cursor. If the right is down, we're moving in a positive direction on the axis. So we're going to add the acceleration factor. Remember, I talked about that before. This acceleration factor, which I hard-coded in here, determines how much the player accelerates and decelerates. So I found 8 was a good playable number, which is why I set that acceleration and deceleration here to 8. We could adjust that number in one place, and we can play with how much the user's object, the cursor, accelerates or decelerates. So this deals with the cursor to the right, the up key, and the down key, right? Because we turned on those keys, left, right, up, and down. So we're testing if those keys are down, we'll react appropriately either with the speed along the x-axis or the speed along the y-axis and adjust the player's velocity accordingly. And you'll notice in the gameplay, because we're adjusting velocity, as I hold the up key down, we move faster. As I hold the down key down, we accelerate. So kind of like real life motion, we can accelerate and decelerate our object, which is our crosshair. Now, this is the key here. We're going to also test to see if the enter key is down. Now I used just down here instead of is down. Is down continues to fire. As long as I hold the key down, is down keeps firing this event and we keep accelerating. With the enter key, I didn't want it to fire again and again, so we use just down. It detects the down key event once. So we'll play the shot sound. And what this does is it tests whether or not we hit. And what we're simply saying here is if the difference in the X position of the player and the alien is less than the accuracy factor, which we set to 50, and the distance on the y-axis between the player and the alien is less than the accuracy factor, then we've hit, else we've missed. So this uses absolute value to ignore essentially the positive or negative outcome and simply see whether we're within 50 pixels. So that'll run a function called hit if we've hit. So if we're within 50 pixels, it's a hit. If we're not, it's a miss. So the hit function plays the hit sound, increases the user's score by 10 and displays that score. Then we play the explosion animation. And when that explosion animation is complete, we essentially reset the player and the alien. So this runs first. This plays the explosion animation. And this line detects when that animation is complete. And again plays the cycle animation, which is the alien rocking back and forth, and resets the player. All reset player does is moves the player back to the center of the screen and sets its speed and velocity to 0. Because you'll notice every time you hit, that reset player function runs and moves the player back to the center of the screen. So that code right here is doing that. If we miss, the user gets a penalty, the score is reduced by 1, and that new score is displayed. And that's essentially how the game works. When the game ends, we destroy the alien and player objects, we remove the timer text, and we clear the interval timer. So all of that code, those 200 lines, make up this very simple but very playable game. Thanks so much for watching this episode of Build. My name is Mark Lassoff. I hope you enjoyed putting together our game in JavaScript and Phaser.js. I'll see you on a future episode of Build here on Framework Television.